So let's go on to checkpoint 9. So this checkpoint 9 I've roughly gone through in the lecture, but just to recap. So given this successive IE, so this must be the first IE, second IE, third IE, fourth IE, fifth, sixth, seventh. Okay, so again, it's very simple. Just need to take your calculator, calculate the difference between first and the second, second and the third, third, fourth, and you realize that between the 6 and the 7, there is a greatest jump in IE, okay? The difference is the greatest. And from here, you just need to, okay, you just need to see that after the 6th electron, there is a great jump. So that means the element must have 6 valence electrons, okay? Because this 7th is actually removed from inner quantum shell. Okay, so since it has 6 valence electron, out of all these options, just check your periodic table. You realize that option C, okay, which is this tellurium, it is in group 6. Okay, so it will be our answer, okay, because group 6 will have 6 valence electrons. Okay, so it's quite simple. So next thing, for checkpoint 10, we have this 7, okay, first 7 IE of an element, so it's given also. So they ask us to deduce the number of electrons in the outer shell of the element, simply just asking what is the number of valence electrons. Very simple, just use your calculator, calculate the difference between the first, the second, okay, second and the third, third and the fourth, okay, fifth, sixth, 7. So after you calculated, right, you will realize that between the 4th and the 5th, okay, there will be a greatest jump. So in this case, that means number of valence electrons must be 4 valence electrons. Okay, so next thing, if you look at hence deduce the group in which to which the element belongs. So it has 4 valence electrons. It must mean that it must be in group 4. Okay, it must be in group 4. Easy. And lastly, write down the electronic configuration of the element. So in this case, we know that it is from group 4, but we don't know what is exactly the element. So we cannot use this method 1s, 2s, 2p, 3s, 3p, 3d, and etc. to fill in. But what we do know that it is from group 4. So from this information, we can simply write down the valence electronic configuration of the element. So you can add in one word over here, valence electronic configuration. Okay, and in the previous part of the lecture, for elements in group 1, of course there is 1 valence electrons, and so the valence shell electronic configuration is NS1. Okay, similarly you go down the table, group 2 will have 2 valence electron, NS2. Group 3 will have 3 valence electrons in NS2 and P1. You realize 2 plus 1 is equals to 3, and so on and so forth. So that means in this case, since you have already determined it has 4 valence electrons, we know that it is in group 4. So the valence shell electronic configuration will simply just be NS2 and P2. Okay? NS2 and P2. So this will be the answer for part C.